Okay, this is question number 7 of 6D. So what's question 7 all about? Okay, so these are draw handles, cross sections. First rectangle is the first shape is a rectangle ABCD with a semicircle stuck on. Areas, so the dimensions of the rectangle are D and 2D, which means that D is just the radius of the circle stuck on. This one has a radius of 2D and an angle there of theta. And apparently the areas of the two shapes are equal. Okay, so this will be some naming, stating, and equating. The area of the figure on the left is half 2d squared theta, and the area of the shape on, so that's the shape on the right. The area of the shape on the left is the area of a rectangle plus half the area of a circle. Do a bit of tidying of this. 2d squared plus half pi d squared equals half 4d squared theta. I'm going to double everything. 4d squared plus pi d squared equals 4d squared theta. I'm going to divide everything by d squared. Okay, that's enough to be getting on with. Now I'm actually going to read the question. Part A was to prove that theta equals 1 plus a quarter pi. Well, this thing that I've been working on should be pretty good for that. I'm just going to get theta by itself. So theta equals 1 plus, there we go, we're done. So that's part A. Oh, in part B, we're told that D is 3. So we now need the perimeter of shape X. The perimeter of shape X is therefore 3 across the top, 6 down the left, 3 across the bottom, plus half the circumference of a circle, so half 2 pi r. Tidy that up. 12 plus 6 pi. So that's the perimeter of the shape on the left. The perimeter of the shape on the right is the straight section at the top, that's this, plus the straight section at the bottom, that's this, plus the arc length, which is r theta, so that's 2d, so that's 6, times 1 plus pi over 4. I borrowed that from up here. So I'll just tidy this up. That's 12 plus 6 plus 3 pi over 2, which is 18 plus 3 pi over 2. So that's that. And part D is just the difference in perimeters. Just work that on a calculator, work that on a calculator, and work that on a calculator, work that on a calculator, and subtract. Question number 8. So the diagram shows a circle with center O and radius 6. There's this minor segment over here which has area, oh no, that's called R1, and it's got area A1. major segment over here, R2 of area A2. If you made a little triangle here using that chord, the angle at the center of that triangle, at the center of the circle, at the top of the triangle would be theta. It's given us that name, and now we've got to show a whole bunch of stuff. Okay, so I'll just get in the groove. So this is question 8. I don't know why I drew that on, it's a bit messy. This is a perfectly good diagram. Okay, well we have a formula for the area of a minor segment. It's half r squared theta minus sine theta in a bracket. So that's half 6 squared theta minus sine theta, which for us is 18 theta minus sine theta. So that's part A. I just wanted the area of the minor segment. Now, in part B, or prior to part